Okay, hello again. This time in a different role. As Roman said, I work at Seznam as the head of research, but today I'm not gonna talk about what we do at Seznam. Instead, I will be speaking about something which has seemingly nothing to do with Seznam. It is the poetry. More specifically, I will be speaking about the role of poetry, the role of artificial intelligence in poetry. I had a dream. When I was a young boy, I was a very passionate reader, and I dreamt about writing my own book. But you know, writing a book is a hard work, and I am a lazy man, so I've never written anything. Until last week. Last week, I turned my dream into the reality. On this slide, this screenshot has been taken on one of the biggest internet bookstores, online bookstores in the Czech Republic. And what you can see is my book. The only problem with this book is that I didn't write it. I didn't write it at all. The only thing I did is that I wrote a computer program which generated this book instead of me. Even the name of the book was generated by the computer. And today, I'd like to tell you a story about turning an idea or a dream into a real product. In the beginning was an impulse. This impulse, in this case, was a blog post written by Andrej Karpathy. Andrej is a PhD student at Stanford, and this blog post was about language modeling. For those of you who are not familiar with language models are mathematical models which compute a probability of a sentence or of a sequence of words or even sequence of characters. And those language models are very useful, for example, in speech recognition, where we, when analyzing the signals, we have many possibilities how to rewrite the sound, and based on these language models, we can choose the best one, the most probable one. But such language models can also be used for generating new text. And this was the case. This was what Andrej Karpathy did. He trained his language model based on recurrent neural networks on a corpus of mathematical articles, and he generated new articles. This is an example of its outcome. It's probably hard for you to read it because the font is small, but on the first sight it looks like a perfect mathematical article. But if you read it more carefully, you can notice that many of the sentences doesn't make sense. But he also tried, for example, to train his language model on Shakespeare's plays, and he generated new Shakespeare. And as similarly, it also looked like Shakespeare, but the sentences weren't hadn't any meaning sometimes. But the result was quite impressive. So I decided to try it for the Czech language. But instead of generating mathematical articles or long text, I decided to generate poetry. And it had two reasons. The first reason is that generated poetry seems to be quite amazing, especially for people who don't know how the mathematics behind it works. And the second reason is that generating poetry is actually much easier than generating long texts, because in poetry there's a freedom of interpretation, and there are usually many ways how to interpret the poem. So it is easier, and moreover, poems are usually quite short, so it is also an advantage. So I crawled a web server, which is the name of the web server is supermusic.sk. It's a server full of Czech and Slovak lyrics, and I used the algorithm by Andrej Karpaty with slight modifications, and I trained my own language model on it. And this is the result. On the left-hand side, you can see the original generated version. On the right side is my poor translation into English, but I will read it out, the English version. The name is Autumn Song. Why don't you kill yourself? A phone call isn't hope. This planet is still your home. Your time is still going on. Then it continues, na 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 na, you know, because it is a song. And then, I know I'm revealing a book of dreams. I'll find out I'm nothing more than this. So you can notice this, that the algorithm, even though it generates the text character by character, it generates reasonable words, even grammatically, syntactically, the rhymes are correct, and there's also some meaning in it. But as long as the text is too long, the algorithm forgets what was on the beginning, because it has limited memory. So, for example, these two lines are quite far from what was written at the beginning. That's why short poems were usually better. There's another example, a very short poem or lyric. The name is You Aren't Tamara, and You Are Ludmila. Tamara and Ludmila are Czech names of women. So it's quite funny, but you know, it's not bad. So I generated several poems or lyrics and published it on my blog. And what happened really amazed me. The blog post got 1,000 Facebook likes in one day, and I get in 1 week I get 2 offers from publishers. They wanted to publish book of generated poems, which was amazing. So I decided to work on this problem more precisely. In the meantime, Google published this open source version of their framework for machine learning or artificial intelligence. It's called TensorFlow. You've already heard today about it. How many of you know TensorFlow? Okay, most of you, that's great. So it is a framework or a library for very efficient computations using GPUs. So I rewrote the implementation of Andrej Karpaty, which was originally in Torch. And I rewrote it into TensorFlow because I don't like Lua. And this is how the simple language model looks like. This is the most technical slide, I promise. As I said, the generating of the poems works letter by letter. So the goal of the algorithm is based on the history, predict the next letter. And it is trained in this way. So here we have an input of the first step. It is P. It is represented as a vector. And we have a neural network. In this case, it is long short-term. It is a recurrent neural network based on a long short-term memory. And it is taught to predict the probability of the next letter. So the output of this network is a probability distribution over all letters, and we can sample from this distribution and sample, for example, O. And we take O as the input of the next step and generate the next, and so on and so on. But I forgot to say one important thing. We also use the history represented as a hidden state of from the previous step. So the input is not only the letter, but also the history compressed using the neural network. So this is how language models work. But I didn't want to create a language model. I wanted to create a poem generator. So this is the architecture of my generator. It has two parts. The first part is a title generator, and the second part is body generator. The title generator works exactly like the language model. So it is initialized randomly, and it generates. It is the training data is a corpus of titles, and the goal of this component is to generate new title. But then, when we want to generate the body, we don't initialize it randomly, but we use the memory state from the title as the initialization of this generator. Moreover, this memory state is available at every step of the generating process. So it doesn't have a problem with forgetting. This information about the topic of the poem is available through the whole process. Okay, this is how the poems were generated. But we can slightly modify this architecture and use it for something different. For example, we have a perfect name for a poem, but we are lazy to create the poem itself. So we can force the title generator to generate the title we want. It is pretty simple. And we use the resulting memory state to initialize the body generator. So the body is then generated on the same topic as the title. And we can modify it in a different way. For example, we have a great poem, but we don't know how to name it. So we can modify the architecture and force the body generator to generate our poem, and then use the memory state to generate new title. Pretty straightforward, and it is very easy to implement it in TensorFlow. So I wanted to generate poems, so I created a corpus from Písmak, which is a Czech server where non-professional writers publish their novels or poems. I created a corpus of 60 or 80,000 poems, and I trained a generator of poems, and the result is this book. Here are some examples. The first, I will read them out. The first one is called, the name is November. I'm falling asleep, crying, dying, thinking. What do you feel? I feel your weakness and whiskey. So it is, as you can see, it is a little bit better than the previous version. I have another example. This time I will read it in Czech because there's a very simple but funny rhyme and it was hard to translate it into English. Spravedlnost. Na tvou dekadentní duši, ráno i v poledne, Bůh má připravenou kuši. Okay, so those were two examples. They are not bad, but there's something more inside. For example, the algorithm is able to generate new metaphors. I have two examples. The first one is body full of blush of dawn. Blush of dawn means it's the red sky in the morning or in the evening. And actually this metaphor refers to harmed or dead body in one poem. Another generated metaphor is as rare as leaves of trees, and this time this metaphor referred to something which is anything but not rare, so it's also a nice metaphor. Of course, I try to look at the corpus and find this metaphor in the corpus, but I didn't find them. So the algorithm, the neural network is able to create metaphors. It's amazing, right? Maybe you ask, how is that possible? The answer is simple. There's no magic behind it. The answer is computational power. The algorithm I used are 10 or 20 years old. There's nothing new. But if I try to create this 5 or 10 years ago, the learning process would take 2 years. Today, it takes two days. So it is amazing. But you may also ask for any really meaningful application, because poems are fine, but who cares? Actually, there are many applications of such recurrent neural networks. I've already mentioned language models, but we have also many applications at Seznam. For example, we can use recurrent neural networks for the task which is called image captioning. So we have an image and we can train a neural network to describe what's the content of the image. Or another application we use it for the task which is called entity recognition, because we can modify it and instead of predicting next letter, we can predict the boundaries between entities. Or we can predict, for example, sentiment of a sentence using recurrent neural networks. So there are many applications, and this is my message from this talk. Even though something may seem to be impossible, probably it's not. And machine learning can help you to solve seemingly very complex problems. So now go and be memorable. Thank you. and we have like 7 minutes for questions.
How many copies did you sell?
Sorry?
How many copies of the book did you sell?
It's for free. You can download it for free.
How many downloads then?
It's available for 1 week, and already we have about 3,000 downloads.
Thank you for your presentation. I would like to ask, do you need still to have a human judgment to filter out the meaningful poems? So how many poems did you generate and how many did you filter out?
Yes, I would say that this is the same as when a real poet creates his poem.
What's the ratio?
He doesn't publish everything, so I have to select some of them, and the ratio of successful selection is about 1 to 50 in the newest algorithm.
So some of your poems, or one of the poems actually did rhyme. Can your neural network actually make poems rhyme, or would you need to do something else to make them rhyme in the way that Czech poems usually do?
It would be definitely possible, but the problem is that I hadn't so many training examples with rhymes. So the training database consisted of different poems, some of them without rhymes.
So what do you think that they could generally learn rhyming just from seeing rhyming poems, or?
Yes, I think so.
Have you signed the contract?
Not yet.
Do you plan to publish the book or make a printed version?
Sorry?
Do you plan to have a printed version?
Maybe this book is only an e-book, but why not to create another book, or better book, and maybe this will be sold in a printed version.
With matching pictures?
Yes.
Okay. Jirka, did you check the original data if they do not contain exactly the same poems, or at least exactly the same lines?
Yes, I definitely did it, and the created poems are completely new. The network is even able to create new words. For example, one example is in Czech, pokropání. Who knows what it means, but it's a nice word.
So, I understand you said that you selected at the end of the process, choosing the ones that you
Yes.
like and the ones you don't like. Would it be possible to make selections by a human being, guide the process to an interesting result?
It's a great idea. I didn't try it, but theoretically it would be possible. Thank you.
I don't have a question, I have just a comment. I would like to encourage young students here to create, being inspired by you, to create their own master thesis and PhD thesis generators.
Did you consider to do author's reading of those poems? Some speech synthesis, did some like the emotional stuff.
There's a philosophical question: who is the author? The computer or the authors of the poems from the training data? So,
have you considered to apply some principles to generate music rather than poems?
it's my maybe next step. Yes, it's very straightforward, and I'd like to try it.
Well, I guess there are no reviews yet, but I'd still be wondering if you plan to, for instance, send the poems to some anonymous contest. You have no evaluation by the critics or human authors, right?
I actually sent it to one critic, and I didn't tell him that it was generated by computer, of course. And the review wasn't bad, wasn't good, because I asked him if the poems are good enough to publish it and sell it. So he was quite tough. It wasn't definitely rejected, but it wasn't very positive, of course.
Okay, but it's comparable.
Definitely he doesn't notice that it wasn't created by a human, that it was generated by a computer. And I'd like to add that the quality of the poems reflects the quality of the training data. So at Bismarck there are anybody can publish them. So it is the poems are average. If I used a corpus of cipher, for example, the quality would be much higher. Okay, and I think we have no time, so thank you for your attention.